MAT 1033 Final Exam Review Question 24. We're supposed to solve by completing the square, and our equation is z squared plus 12z plus 24 equals 0. The equation is written in standard form. A is 1, B is 12, C is 24. We're going to move the constant to the other side. So I'm going to subtract 24 from both sides. We have z squared plus 12z equals negative 24. And then to complete the square, I'm going to add 1/2 times b over a, which is 12 over 1 squared, to both sides. And that would give us z squared plus 12z plus half of 12 is 6. 6 squared is 36. So we're going to be adding 36 to both sides. Factor the polynomial containing the variable. We need two binomials, z and z. Factors of 36, that would equal 12. And remember, we're trying to form a perfect square. So we would use 6 and 6, both addition in the binomials, so that we can write this as z plus 6, that quantity squared. On the right hand side, we have negative 24 plus 36, which is 12. And we'll bring that on down. Okay. Now we're going to take the square root of both sides. We end up with z plus 6 is equal to plus or minus the square root of 12. Subtract 6 from both sides. We get z is equal to negative 6 plus or minus square root of 12. And square root of 12 has a perfect square factor. So z is equal to negative 6 plus or minus 3 times 4. Square root of 4 is 2. And that gives us 2 square root of 3 for the simplest form. So the two solutions are negative 6 plus or minus 2 square root of 3. And of course we would check that by plugging each one of them in to the original equation to make sure it makes it true. MAT 1033 Final Exam Review Question number 25. We are to solve by completing the square. The equation is 2x squared plus 12x plus 3 equals 0. And we have standard form. A is equal to 2, B is equal to 12, C is equal to 3. Now, since A is not equal to 1, we must divide through by A as our first step, since we already have standard form. We have x squared plus 6x plus 3 halves equals 0. We're going to subtract 3 halves from both sides, moving that constant. That gives us x squared plus 6x equals negative 3 halves. Negative 3 halves on the right hand side. Okay, then we're going to add 1/2 times b over a. Now b over a is 12 over 2, which is 6, so we could use the 12 over 2 if we wanted to show that, but keep in mind that that would reduce. 2 goes into 12 6 times, and then so ultimately we're taking half of 6 and squaring it because this is b over a. So I'm going to end up adding the same thing to both sides, 1/2 times 12 over 2 squared, and that number, half of 6, is 3. 3 squared is 9. So I'm going to be adding 9 to both sides. X squared plus 6x plus 9 is equal to negative 3 over 2 plus 9. Okay, coming up here to the top, we've got x squared plus 6x plus 9 is equal to negative 3 halves plus 9 over 1. Got to get a common denominator. Multiply by 2, that's 18, negative 3 plus 18 on the right, and we're going to factor on the left, x and plus 3 and plus 3, and this is going to give us 15 over 2 when adding those fractions. So now we have x plus 3 quantity squared is equal to 15 over 2. We're going to take the square root of both sides, end up with plus or minus the square root of 15 halves. Our two solutions right now, subtracting 3 from both sides, are negative 3 plus or minus the square root of 15 halves. But we can't leave a fraction for a radicand, so we've got to simplify the square root of 15 halves. X is equal to negative 3 plus or minus using the quotient rule for radicals. I'm going to split this and give each the top and bottom its own symbol. And then of course we're going to have to end up rationalizing the denominator. So the two solutions are negative 3 plus or minus the square root of 30 over square root of 2 times square root of 2. They both have a symbol, so we can multiply, bring them together. That's square root of 4. That's square root of 4, which is 2. And those are the two solutions.